So there are still the exercises from yesterday, which are about using the code, more or less in growing order of difficulty. And for 3, okay. In the past, I was very ambitious for these workshops. I was putting lots of difficult exercises in category 3, but in few hours, you cannot do too much anyway. So I only give 3 very simple ones, but even if they are very simple, doing all of them would still take 1 hour to the most skilled people, I think. You can choose the one you want. Here, you just learn how to put a new input parameter, but without complicated physics behind. It's just that you want a new format for giving information to the input module. So you will only have to modify the input module to tell the code how to interpret eta b. Eta b is a parameter that people working on nucleosynthesis or particle physics in the early universe like very much. Eta b is a baryon asymmetry parameter. So it has to do with the baryon number over entropy in the universe. And it's an alternative way to specify the baryon density. So this is really very simple. But if you know how to do it, you know how to modify the input module for any purpose. Here, you are supposed to do a very simple modification of gravity. If you are expert in modified gravity, you will realize that it's not a self-consistent modification and that it's not a possible model. But okay, formally, you can say, I take my Einstein equation, and this is an Einstein equation in the synchronous gauge with the 2 variable eta and h. So normally, this Einstein equation looks like this combination is equal to minus 4 pi j a square rho total delta total. And I could modify gravity by putting here an arbitrary function of k and tau. And we can play with a function which is 1 plus a scale factor to the 3. It's a model that has been discussed actually in some papers. I think you can find people by Eric Linder from many years ago where this was tried. And it means that at late time, when the scale factor becomes big, then you will get a modification of gravity. So there you need to play with the perturbation module and to do plots to see how your modification of gravity changes the CLs and the pK. The third one is to make a comparison between perturbations in the Newtonian and synchronous gauge. We have seen yesterday that you can output the evolution of quantities of perturbations as a function of time. And the code has a list of predefined values for this. When you use this field k output value, you can see the evolution as a function of time of the delta quantity, the theta quantity, and some metric variables, but not all of them. So for the purpose of this exercise, you will find that the variable that I am asking you to compare in the Newtonian and in the synchronous gauge is not passed in output when you use k output values. So you will have to add it in a given function and then do a plot in which this evolution is compared in the 2 gauges. Okay, and we are here available for help if needed.